And there are even some rules or properties of radicals that apply. Radicals are technically the same thing as exponents anyway, so we can actually apply the rule. So if I'm doing multiplication between two radicals with the same base, in this case, then I can express them as a single radical. So if I'm taking the square root of a and the square root of b and multiplying that, then I can say that it's the square root of a times b, right? So that is just like the power rule. It's the same, I'm taking the same root. And same thing with quotient. If I'm taking the square root of a and the square root of b, then it is the square root of a over b, even if it's cubic root, but it has to be taking the same root. And if I'm taking the root of a root, then I am just multiplying whatever those roots are and taking one single root. So I just multiply m times n. So it's almost like the power of a power law, where I multiply the exponents. In this case, I multiply the root. So if I'm taking this cubic root of the square root of something, well, the cubic root of a square root, 2 times 3 would be 6, right? So I would have, so if I were to take the cubic root of the square root of a, then I know that would be the 6th root of a, just as an example. Now, one thing I want to be careful of is if I have a situation where, let's say I'm taking the 4th root of, let's say, 16 times a to the power 4, right? Well, I know that I could say that the 4th root of 16, 2 times 2 times 2 times 2, so it's 2 to the power 4. It's the same thing as saying the 4th root of 2 to the power 4 times a to the power 4, right? So, and I can can evaluate those independently. Well, the 4th root of 2 to the power 4, the powers cancel each other out. Same thing with a to the power 4, right? So I end up with 2 times a, arguably. But since it's an even exponent, I have to assume, I have to say that I'm writing down the absolute value. So it could be positive or negative because it's an even exponent and an even root. But if I'm taking the 5th root, let's just say, because now I have the odd number, if I'm taking the 5th root of, let's say, 32 times x to the power 5, well, once again, I know that that is the same as 2 to the power 5, the 5th root of 2 to the power 5, and x to the power 5. So once again, I know, well, in this case, it's the power is canceled out by the root, so I am left with 2, and the result is just x in this case. So whatever is the value of x, okay, will be what it is, whereas whatever is the value of a could be positive, could be negative. So just be careful with that when you're dealing with radicals.